Hello everyone, I'm Giorgi Akhalaia from Georgia. Let's briefly introduce myself. I'm cybersecurity researcher at Caucasus University, and also I work with Scientific Cybersecurity Association of Georgia, which is an exclusive representative of the Bit Sentinel in the region. So we are teaching the students penetration testing using CyberEdu platform and making penetration testing in the region, in Europe, and for local companies. I'm managing scientific GNSS network of Georgia. It's a navigation system of Georgia. We are making local reference systems to maximize the location of the devices for civil, military, and for end-user cases. Actually, this was a idea of why today I'm going to talk about device tracking, but connected to the cybersecurity, in our case, in 5G network. Today I will talk about the device tracking threats in 5G network for end users. First of all, let's start from the starting point. During the last period, the rate of developing mobile devices has increased. So now you see the number of devices and population as a graph. The yellow ones are the number of populations, and the blue ones are the number of devices per user and in the world. And as you see, there are too many devices which are operating over the wireless network. So the developing these devices itself triggered to start working on the new standards of mobile communications, because existing standards 4G, 3G, and previous one was not enough to provide the service, enough and high reliable services for these devices. So the engineers started working on the new standards, as you see, as you know, the new standards, functionalities, devices, services always comes and arise new threats and vulnerabilities in the cybersecurity. So our study was about what the new threats related to the 5G network changes, related to the infrastructure and the design. So we have compared existing threats, existing method of locating devices, and tried to test it in 5G network. So these were the three objectives. How does the 5G architecture affect on the user equipment, location privacy? Which band is more vulnerable? And I will explain the idea of this question. And the last one is to track device in mobile networks using this vulnerability. So first of all, let's see the scope of the 5G network. The three KPIs is to achieve the bandwidth more than 10 gigabit per second. And as you see, the target market of this network is quite big. It starts from the end users and end with critical services like emergency, healthcare, military, and so on, virtual reality, AI, and so on. So the scope is so big, and incorporating different industries into one huge network also is very vulnerable, and the security should be in a high level. The latency of the standards will be up to 1 millisecond, and the number of devices is also increased. And this is one good point of the standards. And for these reasons, there are some technical changes that should be done to achieve these requirements from 3GPP. In our case, our point of interest is operating spectrum. The first category will be low band, which is below 1 gigahertz. And this is used in highly populated areas because the frequencies below 1 gigahertz is less affected by the buildings and building materials, and I will explain this idea a bit later. The second band will be, but the limitation is a bandwidth because it's about up to 100 megabit per second. Also, the mid band, it's from 1 gigahertz to 6 gigahertz. The bandwidth is higher than previous one, but it's more affected by the buildings and other objectives. Because as we know, that as we increase the frequency, it will be more affected by the buildings and any other objects. I will explain this idea and what kind of objectives are limiting bandwidth and the coverage and the distance of the network. And the last one is a high band from 6 gigahertz to 100 gigahertz. Actually, this band promises all the benefits of the 5G networks. And our target of this research was this category, how it helps us to locate the device without knowing 2, 3 or more cell towers. Our goal was to try and locate the device only by one cell tower, to determine its location on the Earth. I will explain this idea. So, to start with the method of locating devices, the concept of determining the location of the devices for different methods or techniques are the same. We need the reference system and we need the receiver device. Generally, these systems are GPS satellites. GPS is a familiar name, but the correct one is a GNSS because the GPS are the satellite from US. There are also Galileo, GLONASS, and so on. And the other type is a AGPS, SST GPS, which stands for determining our locations by cell towers provided our network operators, telecom operators. So in any case, device is trying to calculate its locations on the Earth by measuring the signal got by the satellite from the satellite, or calculate its locations by the data cached by the cell towers. So let's let's compare each other. So the first one on the right one, it's not right, but left one, it's GNSS, also called GPS, and we have the device and we're tracking the signals sent by the navigation systems. In our case, by the satellites which are operating in low orbit over the air. So actually, this is the most precise technique to calculate our location. You can achieve up to 1 millimeter per 1 millimeter for coordinators, but it has some limitations. So because it's are traveling over the different layers of the Earth, like ionosphere, so it's affected by number of electrons in the ionosphere, also the building, precipitation, and so on. And the next one is AGPS. When we get the information from cell towers and printing the circles and calculating, finding our cross-section, and that's our locations. Both of them has some limitations, and I will explain all of them. So this is how, in case of AGPS, we are calculating device locations. So the first one is to print the circles, and the cross-section is our probable location. In some countries, it's regulated by the government that network operators are required to set up their cell towers to provide these coordinators, latitude and longitude, so precise that in case of emergency or military, the emergency guy should be able to determine our phone's locations. Network operators also are trying to find our locations by this information. So our cell phones always are running background this process to find nearby cell towers, and by default all the cell towers are sending its ID, which is unique in the network, and also latitude and longitude. So if I know their location and I know possible distance of spreading the signal, I can determine my possible location. So it's called trilateration, and also the next one is a triangulation. But it's for ideal cases, and it's for low frequency signal, because as there are buildings, high frequency signals will be affected by the building, so there will be the bias. In 5G network, in the previous networks also, the attach process, when our cell phones are trying to connect to the cell tower, the request is sent in unencrypted way. It means that if someone will catch our request or sniff our request to the cell tower, he or she will be able to modify some parameters, like modify to disable power saving or disable the roaming. Your cell phone, no matter how strong signal do you have, every time scans the nearby cell towers to find the strongest one and try to make roaming, to switch from one cell tower to another one. In 5G network and also in 4G network, it's able to make fake base stations and catch these signals. I mean, if I create a fake cell towers in this room, I will be able to catch your signals from your phone. When your phone tries to find a new cell tower, it will measure the signal strength from my fake tower and the tower of your telecom operators, and because I'm near to your cell tower and signal will be the stronger one, your connection will be, your device will be connected to my tower. So after that, I will be able to sniff your connection or disable some parameters. It was a problem in 4G network, but for 5G network it's crucial because of the scope of the network and because of the emergency services. When also our device is at the same time is connected only on one tower, but the device has a list of nearby towers. Visible cell towers. So when I'm catching the information for the record of the all cell towers from your device, I will be able to calculate your location without your permission. And I will demonstrate how easy it is. In that case, on the slide you see the real towers and fake ones, and it's simple that when you have fake inputs, when I saw your list of the towers and there are fake inputs, so I am not able to find your exact locations. So it gives me ability to make some mistakes and relocate your device in case of emergency. The first thing when we were trying to catch the GNSS data, which is more precise in the world of calculating horizontal location or horizontal movement of the device, it's not useful because it's too noisy, as it requires user permission and user interaction from our device, because of the security, device always is printing that someone is catching your coordinates or trying to steal GPS coordinates from your device. Also, for that reason, a GPS module or hardware should be enabled and switched on your device. If you disable for the security, no one will be able to steal this information from your phones or any other devices. Also, the limitation here comes because it requires an open sky to have a good satellite view, and the satellite geometry on the sky should be the better. In other case, no matter you might have the record from 10 or 12 satellites, but if the geometry is not good, you will not be able to locate any device. So in that case, GPS signal is not enough. Another limitation of this technique was that total electron concentration content on the ionosphere, when the signal is sent by the satellite, it is affected by the electrons in the ionosphere, so your location is not so precise, sometimes to use by emergency cases. Also, when we are in the building, we are not able to locate our phones, and in that case, we need the information from cell towers. As I have mentioned, cell towers usually spread the information about themselves by default. It's like when we have the beacon packet from the wireless access points, by this access point is sending that it's available for the connection, and there are also important parameters of the security, like if the protection from the authentication and something like this is enabled or not. In our case, cell towers are also sending the information about the ID of the network, country code, region code, and their personal IDs. So as it's sent by default, we can go through the streets, walk by the softwares enabled, which will be able to collect all the cell towers, and by the then by any software like ArcGIS or ArcMap, we can plot all these maps. Also, we need the digital elevation model of the country, our point of interest, and in this case, we can plot all the satellites and make a coverage map of the network. And then when I know which satellites, which cell towers are visible to your devices, I will be able to find your exact locations. It works for 4G, 3G networks, but it's not precise because of the frequency. So it's a low frequency network, and it's not necessary to be near to the cell tower to go catch the signal and to join the network. Also the limitation here is that telecom operators are trying to cover and provide a good service, and in the previous generation networks, if there are too many satellites, not the satellites, but cell towers, sometimes there a problem to find. Sometimes the cross-section is too big to locate the device exactly. You might determine the street number, city, or part of the city, but you will not be able to determine the location with an accuracy of 5 meters. It's a problem of the previous networks, and why the telecom operators or security guys need some time to calculate our locations. So it's not as easy as it seems. Also, there are some studies or researches that the signal strength might be considered during the calculation of the location, but because of the frequency and regulations by some countries, it's complicated and it's not useful. And I will explain why. Telecom operators and wireless technologies are operating on the radio frequency using radio frequency, which is a part of electromagnetic waves. So it's also called RF abbreviation, and it depends on the physics, and everything which happens to the radio waves also happens to the telecom networks. There are also the technology, not technology, but guys who are carrying the pollution from radio frequencies, and they are trying to make some regulations, and in some countries this regulation is already operating. They are changing the building materials or specific isolations that protects, for example, pregnant women or children, or any other guys with implants from radio frequencies, because according to the researches and tests, medical implants, pregnant and children should protect itself or themselves from the over number of radio frequencies. So every these limitations and every kind of the protection from the radio frequencies will affect on the telecom operators. It's also affect on the 4G network, but it's crucial for the 5G network as it uses higher frequencies from 6 to 100 gigahertz. This is a simple illustration that when the wave is going from one environment to another one, it reflects or refracts, and so it has some modifications, so it loses the quality, which then will get a less speed or increased latency, and it's more visible in case of high frequency waves. In normal cases, when we are talking about the telecom operators, we calculate a free space loss. It's in normal case, it's atmosphere loss, and in that case, we have to consider the building, weather conditions, and so on, which happens on the Earth. This is a normal case when we have one transmitter which sends a signal and then another one who receives the signals, and there's a medium where we lose the quality of the signal and we lose the time, so the latency is increased. In our case, to summarize the limitations, building materials will protect the humans from the 5G network, but it will cause the limitations for critical services to be operated under 5G networks. So now in 5G network, if your device needs to connect to the high band from 6 gigahertz to 100 gigahertz, it should be near to these cell towers. If you are far from this kind of tower, your mobile will automatically switch to another tower, which is where the distance is much more, so the locating your device will be difficult. So when I know that my device is connected to the high band, I know that I am near to the cell tower, and knowing only ID and the latitude and longitude, which is open, I can determine my location. So we tried to catch the signal, the attach request, when the device were trying to connect to the cell tower and try to modify the target. I mean, target of the network ID, ID of the cell tower, local ID, local region ID, and the network ID. In 4G network, it was quite easy. Here you see the packet details, which can be seen in the Wireshark and look through, because in a background process or simultaneously, the cell towers are communicating with users, and also users, I mean, the devices are communicating with cell towers and trying to say that I am the device with a SIM card with IDs like EMEI and IMSI, and please let me connect to your network. It's a background process, and it happens always. And when we try to catch this information, here's a radio network code identifier 144, and also we have cell identifier. So in that case, we were able to determine on which tower the user was trying to connect. So if we can catch this request, we can modify these parameters and force the user to every time connect to the high band frequency network, no matter of the signal strength. In that case, we'll be able to map all the city and find the exact location by only one cell tower. So this is also one illustration where the IDs of the cell towers are cached, but it's a packet sniffed sent between cell tower and users. So to conclude my presentation is that this process is also able to do in previous generation networks, but because of the frequency, the user is not required to be next to the towers to be connected. In 5G network, because of the some limitations, buildings, objects, the frequency is highly affected by different objects, so we have to be near to the towers. So if the request from the device to the cell tower is sent unencrypted way, I am able to catch this request and modify the target. So the force the device to connect every time or try to connect to the high band network, and in that case I will be able to go find its location without knowing 3 towers, which is not high accuracy at this point. Please questions, if you have any questions. Then thank you for your attention. Yes.
Thank you, Giorgi, for a wonderful presentation. Yes, we have questions in the audience. Hi. You mentioned that for this tracking you need fake cell towers. It's
Fake
something.
cell towers?
Yeah.
Yes.
So it's so easy to create one. So you can use a phone, or what kind of device, modem device do you need to use? Because I suppose this type of chips used in the cell towers are proprietary, so hard to obtain.
Thank you for the question. It was a simulation of microlab set up by the Raspberry Pis and transmitters and receivers, and we have created the one tower that was spreading the same the details as cell tower is spreading, and we were able to catch this request and catch this client from the network.
So
yes.
you can create actually using Raspberry Pi to simulate the
not the real one, but for the simulation, yes.
Okay. And the second question is, now you're tackled with 5G, right? Are you saying that 4G or 3G is much more secure from this perspective?
Thank you for the interesting question. No, we are not approving this one. The same problem is a 4G network, but because of the scope of the network, as the 5G is going to incorporate different industries, and also the portion of the AI will be high, like emergency services, medical devices, health devices, and automation robots. So the security will be more targeted by the attackers than the previous one.
And human implanted chips, I suppose.
Sorry?
Human implanted chips, I suppose. Future, okay. Our future. Yeah, thank you.
Thank you very much.
Thank you, guys. Any other questions from the audience? Yes, I have a raised hand over here.
Do you think in the future this program, the tracking on 5G, will be that big one that the government should step in and do some limitations from the software or reduce the ban in some way?
Okay, so let me repeat your question. You're asking about if I'm working with the government to make some limitations or regulations to block this kind of frequencies or something like this?
Yes, because the tracking would be, I think, too precise in the future, so they should reduce it, or too easy for people to track other people based on 5G.
Okay. Thank you for the question. It's very interesting. Yes, the future goal is to find a solution how to protect ourselves from this tracking. But at this point, I'm not working with the government to find some regulations, because this whole infrastructure and the changing whole infrastructure, from my point of view, is not reasonable. We should find some protecting mechanisms and try to change the whole infrastructure, or try to change the physics. Okay, it's all about we need these frequencies. We need some kind of standards or architecture or the design to get these services. So we should not go and say that let's block, say, high frequency radio waves or high frequency radio waves in telecom communications. I think we should try to find a solution, and now we are working at this point how to minimize the risk of user device tracking. Okay.
Any other questions? Yes, we have another question over here.
Thank you. Did you have opportunity to test your approach?
Okay, thank you for the question. In our case, in Georgia, in Georgia right now, the 5G network is not officially operated. It's provided by the telecom operators for testing purposes. We have set up some funding and bought some devices, and in that case, the simulation was shown only example on 4G network. So it's Like we are talking this with countries with 5G, like Turkey, to find some joint project and to make the testing all this environment and all these ideas and new solutions and functions. So because we are also working some IDS systems and IPS for the 5G network, and we need to test it in a practical way, not in simulation. Thank you.
Awesome. Any other questions in the audience? Yes, no, definite, maybe. Yes, 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 please raise your hands if you have any questions. If not, I have a question. How much of the 5G technology is dependent on the IPv6, if any?
How much the technologies depend on?
For example, in all 5G technologies, you are going to have to communicate over a fast network, and you're going to need some IPs, and how much of the 5G technology is going to be dependent on the IPv6 technology or IPv6 IPs in order to have enough IPs in order to connect. You'll have Internet of Things, as you mentioned. You'll have a lot of devices connected to the same tower, for example, for a 5G. So pretty much you'll need a way to serve the information for all those connected IPs. So IPv4, what you're doing now as technology, when you assign the IP on IPv4 to the next call and so on and so forth, may not be also available if you're going to use different kind of I don't know, protection for devices like medical devices or whatever.
Thank you for the question. Right now, for me, it's difficult to answer this question because I have not researched this topic of area. But I think the idea of the IPv6, when it's the limitation of the IPv4, the numbers that we are going to the IPv6, and I think it's a solution right now. But it's not my my field of studies, so
Okay.
right now I cannot answer the exact question.
Thank you. Oh, we have another question. Yes, let me.
To answer your question, it doesn't matter IPv4 or IPv6 as long as you have enough IP addresses on your network.
Thank you. Great. So, guys, if we don't have any other questions, please. Oh, yes, we do have another question.
Hello. If you want to improve device tracking in a 5G network, can you use faked 5G towers in a spot area or something like that?
For the improving, if you are going to use simulation networks or fake networks, could you specify the question?
Both.
Okay. For the solution, we are going to test every our ideas and solution is a real environment. That's why we are working with the telecom operators and international. We have submitted some fundings to buy all this infrastructure in Georgia to try and start the testing in real environment. Because all the simulations and all the test environment is not enough for developing deployment to the standards. So it should be tested in different environment, but in real one, not the simulation.
Okay, thank you.
Thank you.
Well, thank you. Let's have a big round of applause for Giorgi.